Okay, so welcome back to another video. It's been a while since we've covered anything algebra related, so let's actually solve an equation for x for the reals. We have x to the power log base 16 of 27x equal to 3 to the power 1 divided by log base 3 of 2. So a lot of this stuff is going to be utilizing a lot of log base properties to actually get to solve our equation. I mean, go figure. It is a log base as everything you can see over here. So that's basically just today's video. I don't think it's going to be really too much, or it's got some interesting things that we're going here, but it's not going to be too long or anything, if anything. But it's basically, this is probably a good practice on a way to test your knowledge on if you still remember your log base properties and all that stuff. while working through this, there was some I have to look up to remember the properties because it's actually been a while since I've actually utilized some of these log base properties. So that was quite a fun time, and this one will be a fun time for you if you want to try it out for yourself before we continue. So with that, let me actually just jump right in. So I think it's worth noting that the first property we're going to be using, just to keep this in mind, is that log base of AB is going to equal to 1 divided by log base B and A. So utilizing that, what we're going to do is that we're actually going to change our right side of the equation, so that it leaves us with, x to the power log 16, then 27x. So over here, this will be 3 to the power. So utilizing this formula over here, so that means we're just changing the basis. This is just going to be log base 2 of 3, okay? And then what I'm going to do here, in order to make things a little easier to utilize this, let's actually take log base 2 of both sides of the equation. So log base 2 of x to the power log base 16, 27x. Then now if I do the log base 2 over here, so log base 2, 3, log 2, and then 3 over here. So that means that's the same thing written as, of course, we just moved the exponent to the front. And so that means that this is actually just going to be the same double quantity again. So that means that's just going to be log base 2 of 3 quantity square. Okay, so now what I'm going to do here is that, let's see, so of course, going forward, using that same logic again, I'm actually just going to move the log base 16, 27x up to the front. So now log base 16, 27x. So that quantity is still being multiplied by log base 2 of x. And then of course, we still have our right-hand side. So log base 2, 3 quantity square. Okay, so now this gets interesting. So how do we actually continue forward with this? Well, here's another thing we're going to do over here. So what we're going to pay attention to specifically is our log base 1627x. So there is a nice rule such that we can actually write this in terms of the division based on changing the base of our natural log. So what we have is that we're dealing with over here in order to fix this up. And what we can do here is actually we can change this into the basis of 2. So that's our goal. So by utilizing the 16, so that means the 27 is going to be the 27x and 16 is going to be the input, but our base is going to be 2. But the formula states that utilizing those numbers, so then I have that this is going to be log base 2. So actually, I should probably write this formula first. So the change of base formula states that if you have log base B of A, if you want to change it to a different base, that's the same thing written as log C being our new base we're dealing with, of A, and then divided by log base C of B. So we actually utilize this in terms for the log base 1627. So that means now I have that's 16, then 27x. So then that could be written as log base. Well, we're actually changing this in terms of the 2. So that's what we want to do in order to get everything in terms of the equality together. So that means I have log base 2, 27x, and then divided by log base 2, 16. And then what you'll notice is that log base 2 is 16 that's simply just going to equal 4. So thankfully that makes things a little easier. And simply reduce it down a little bit. 27 is the same thing as 3 to the power 3 and then times x. And so what we can do here, so let me actually just write this. So 1 divided by 4 and then log base 2 of 3 to the power 3 and then times x. So that's actually what we got down here. So that means that's going to change that. But then we have a 3 and a to the power 3 and then x. So what we can do here is actually we can actually utilize even more log properties to write this in terms of a sum because our input is multiplication. So putting this back together, so now I have 3 to the power 4, or 3 divided by 4 of log base 2 of, 3. That's simply because the exponent of 3, just move that to the front. And then add this with 1 divided by 4, then log base 2 of x. All right, and then we're still with multiply with log base 2 of x. And then, of course, we're still with log base 2 of 3, and then quantity square. Okay, so now how do we actually continue forward with this? Let's make things a little simple. Let's actually just multiply 4 into everything so that we're not dealing with fractions. So therefore, I get that this is actually just going to be 3 log base 3. Add this with log base 2 of x. We're still being multiplied by log base 2 of x. And then over here, this is still just going to be, so times 4 log base 2 of 3, and then quantity square. So in order to get things equality down, why don't we actually set the equation equal to 0? So that means I'm actually going to subtract this to the other side. So now this is going to be, let's see. You'll notice that the log base 2 squared, so that means everything I'm going to do here is distributing the log base 2 of x into everything on the left-hand side here. So now we get a square quantity, so log base 2 of x, quantity square, and then add this with 3 log base 2 of 3, and then multiply with log base 2 of x. And then I said we were going to subtract this, so that has a minus 4, and then log base 2 of 3 quantity square, and then we set this equal to 0. So here's what I'm actually going to do. We're actually going to change our middle term a little bit differently. So what I'll do here is that we're actually going to separate it out, so I have a 4 minus 1 of that term. So then this is going to be log base 2x quantity square. I have a plus 4 log base 2, 3, log square x, subtract log base 3 or log base 2 of 3, and then multiply by log base 2 of x, and then we're still with 4 divided by, or 4 times log base 2 of 3 quantity square equals 0. And then you can kind of see where I'm going with this in terms of the expansion. What I can do here is that we can factor out the log base 2 of x from here, and then from these two terms, and from these last two terms, I can factor out a log base 2 of 3. So this is kind of getting interesting because you kind of understand where I'm going with this. If you haven't, we're eventually going to get things in terms of a difference of squares. So before we get to that, let us actually just write everything out in full. So now log base 2 of x. So we factor that out. Over here, the following is going to be log base 2x. Then add this with 4 times log base 2 of 3. And then subtract log base 2 of 3. And then factor that out of log base 2 of x. And then add this with 4 times log base 2 of 3. And then, of course, set this equal to 0. And then, of course, you can factor out the log base 2 of x plus 4 log base 2 of 3 from both sides. And then, so I actually take that back when I say difference of squares. It's going to be in terms of just factoring. I should just use that term, just literally just factoring. So that means now we have the following. So factoring now all that together. So now we have log base 2 of x plus 4 times log base 2 of 3. Then this being multiplied by log base 2 of x, then minus log base 2 of 3, then set this equal to 0. So pretty much we got everything we need. So it's actually, the last step is going to be simple. You just set each of these terms equal to 0 to solve for the x. And it's actually pretty simple to do. So log base 2x plus 4 log 2 of 3, set this equal to 0, which of course you can that log base 2 of x, set this equal to negative 4 log base 2 of 3. So you'll notice that specifically if I solve this by itself, then of course negative 4 goes up to the front. So that means 3 to the negative 4 is basically, 3 to the power 4, that's going to be, negative 81? Yeah, negative 80 or 1 over 81. So then you just set those two inputs equal to each other, and you get that x is simply just equal to 1 divided by 81. All right, so that's one solve. So let's do the other one. So log base 2x minus log 2, 3 equals 0. Solve that. Log base 2x, set this equal to, so now it's going to be positive log 2, 3, and you'll see that x is equal to simply just 3. So therefore, we found our two solutions that satisfy our given equation we want to solve for. 1 divided by 81, and then 3. So just like that, that actually completes our evaluation, well, not really evaluation, but solving for x for the reals to that actually satisfies the following. Everything using in terms of a lot of logarithm properties, and that's a good way to actually test your skill and knowledge if you actually still remember. I certainly still remember some of it, certainly. So everything, it just comes down to these two values. So yeah, that's pretty cool if you ask me.